All right, so let's continue. This is Reactivity 3.4.1.2, and then which is both SLHL, and there's now 3.4.9 to 10, which is HL. So what you would have to know for this one is let's start with the HL part. So, with the SL part, 3.4.1 to 3.4.2. So this is a nucleophilic substitution reaction. So this is one of the main reactions you would have to know in reactivity 3.4. But let's go on. So nucleo comes from the word nucleus. Philic, if you guys like to think about words like pedophile, that means really like children, right? So nucleophilic or nucleophile is something that really likes it, really likes the nucleus, really likes. Okay, so this is what nucleophilic means. It's something that really likes the nucleus. And substitution is replace. So essentially, it's nucleophilic substitution reaction is when a molecule or an atom really likes the nucleus, then they would replace something to react. Okay, so what is a nucleophile? A nucleophile is essentially, as I mentioned, something that really likes the nucleus. We know that the nucleus is composed of, let's say helium. Let's draw it bigger. Say helium nucleus, right? It's composed of protons, neutrons, and neutrons. So overall, disregarding the electrons, the nucleus would have a positive charge. And we know positive attracts negative, so thus something that is highly negative in charge would want to react. Thus, it makes it a nucleophile. And these nucleophiles are always electron efficient or saturated. That's probably a better word, saturated. Saturated with electrons. Hence the negative and positive attraction, okay? So what you would have to know is your partial positives and partial negatives, which I think is the lowercase delta. And you find your partial negatives and positives from, let's say HCl, right? You draw the Lewis dot diagram. There's a lot of electrons on the Cl and no electrons on the hydrogen. Thus, this would be partial negative and partial positive. Now, here comes the question, because these reactions also happen. I forgot if they're electrophilic or nucleophilic, but then just note that although they both have equal amounts of electrons, I think this is electrophilic, but it's good to know. Although they have equal amounts of electrons, one would be partial negative and one would be partial positive. It doesn't matter which one, just know that when it reacts, this is what happens to them, okay? So nucleophilic. Between HCl, the Cl would be the nucleophile, as it is partially negative and it would always want to react with a positive charge. And let's see. And what else? Okay, so let's find a good example. Yes, here. Okay, so let's look at OH minus plus an ethane, and bromoethane. Okay, this would react and create C2H5 alcohol, so an ethanol plus a bromine ion. Okay, So what happens here if we draw out the full thing? It's OH 2, 3, 4. Yeah. This is what happens in OH, and this is how 1, 2, 3, 4, 5. These are all hydrogen, bromine. Okay. So within this bromoethane, because we know that bromine has 3 lone pairs, this would be partial negative and this would be partial positive. And let's make my little laser. Ooh. Why is the okay? So this carbon is now called a carbocation. Hence, carbocation. Cation, positive charge, and carbo, which is a carbon, okay? So this is something good to know. And so what would happen is that we know it's a substitution reaction. So the OH, it would actually come in here, well, the oxygen, because the oxygen is partial negative and the hydrogen is partial positive. So the oxygen will come in and react with this bromine with this carbocation and sub out this bromine. So this would create so it would actually just sub in. And just know that it will always happen if it's in a solution, an aqueous solution. This will always happen. And leaving the bromine on the side, thus creating this, an alcohol and a bromine ion. So this is a standard nucleophilic reaction. A generalized formula that's kind of good to know is this. Nu, standing for nucleophile, negative charge plus a R, X. R is the rest of the chain, as you should have known from structure 3, organic chem, and X is the substrate, or the one that's partial negative. So what this will happen is that you will have R connect to your nucleophile plus your substrate minus, yeah. So this is what happened in a nucleophile reaction. This is the entire part for SO. Now moving on to HO, where we have to learn about SN1s and SN2s. So SN1, SN stands for substitution nucleophile. And the one SN1 means unimolecular. And which means single molecule. So SN1 is a nucleophilic substitution with only one molecule being changed. And SN2, the SN stands for substitution in nucleophile. 2 stands for bimolecular, which means 2 molecules. So it involves the substitution of 2 molecules. With that in mind, let's go up here. I already had this drawn. So we have primary halogen alkanes, secondary halogen alkanes, and tertiary halogen alkanes, okay? And all 3 of them would have primary and tertiary. This would be something you would have to, that's different. So primary, there's an SN2 reaction. So let's take the reaction of chloroethene, Cl with the ethene, with an OH minus, or hydroxide. So what will happen is that because we know this is partially negative, then this is partially positive, forming a carbocation. This is partially negative, partially positive. So this will kind of sub in here, and this is what's going to happen. there's going to be a slow reaction and forming an unstable molecule of an OH here, and the Cl is still here. But we know that Cl only has 4 valence electrons, and it will only want 4 bonds. Otherwise, it'll be highly unstable, because that's just not how chemistry works, So it will try to be stable again. To be stable, this is where substitution comes in. It will be a really fast reaction, and you will form this. It will essentially kick out the Cl and replace the OH here, okay? And something to keep in mind is that it will form a stereoisomer, so your carbon, let me get my little laser. Your carbon, it will flip, and that's something just to keep in mind. And this is in primary halogen alkane, and only SN2 will only happen on primary halogen alkane. You see, the carbon, the chlorine is attached to a carbon that's only attached to another carbon, nothing else. Okay, it's primary halogen alkane, and it essentially subs in for 2 molecules. It joins in the OH, and it kicks out the Cl, forming this. So you see, H, CH, these is all the same, but the OH and Cl. So there's 2. And next is tertiary halogen alkanes, which will form SN1, which is a unimolecular nucleophile substitution. So you have an methyl 1, 2, 3 methyl, 2 methyl, 2 chloro, propane. Okay, this is what you have right now, and this would form an intermediate, so itself would just break apart. You just have to know it will break apart, which then the Cl minus would leave the let's just call it molecule X. We'll leave molecule X and form a carbocation here and itself a negative charge here, okay? Which then, usually it would be OH. It will go in and replace the spot of that Cl, thus forming an alcohol. And I should add this. And a Cl minus, okay? So these are SN1 and SN2s. SN2 replaces 2 molecules, and SN1 replaces only 1. And secondary halogen alkanes, meaning that, let's say Cl is carbon, that's carbon, and H. Like this. It's only bonded to a carbon that has another carbon attached to it. So these are secondary alkanes, and both SN1 and SN2 can happen. But remember that SN2 is unstable, and it's a slow and then fast type. But the SN1 is also slow and fast, but then there is an intermediate in between. And this is it for Reactivity 3. 3.4.1, 3.4.2, 3.4.9, and 3.4.10.